I think we're fine. We should start now. More people will join as we go along, so that's fine. Good evening to, I believe, most of us here. I welcome you all on behalf of the Philosophical Society of St. Stephen's College to this online lecture on the topic Paraconsistency and Dialetheism. And good morning to our distinguished speaker, Dr. Graham Priest, who has very kindly made time out of his busy schedule and is joining us from New York. And it is customary when introducing a speaker of such brilliance by stating that they require no introduction, and then go on and deliver the introduction all the same. And that's what I intend to do, and I wonder what kind of contradiction that is. Maybe we'll get into that. So Professor Priest began his academic journey in mathematics at St. John's College, Cambridge, followed by a doctorate at the London School of Economics. And somewhere along the way, he came to the view, very fortunately for most of us, that philosophy was more fun than mathematics. That decision has led to a remarkable career marked by extremely unique and original contributions to contemporary metaphysics and non-classical logic. Dr. Priest is presently Distinguished Professor of Philosophy at the Graduate Center at City University of New York. He is also Boyce Gibson Professor Emeritus at the University of Melbourne and International Research Fellow at Ruhr University of Bochum. Professor Priest is perhaps best known for his pioneering work in non-classical logic, and in particular for developing and defending the view dialetheism, the view that some contradictions can in fact be true, which is also what we will be hearing about from him today. He has published nearly 240 papers, 6 monographs, and several edited volumes, and has also written widely on metaphysics, Buddhist philosophy, and the history of philosophy. There's so much more, but I can keep going on, but let's stop there and so we can hear from Dr. Priest himself. He will be speaking for roughly 45 to 40 minutes, following which we will open the floor to questions from the audience. So please hold your questions till then. Over to you, Professor.
Thank you, and thank you very much for the kind introduction, Arhant. Let me share my screen. I've forgotten how to do it now. There we go. And then we can get started. So let me see. It's a bit disconcerting when you can't see anyone that you're talking to. So I'm going to leave a few faces on, but hopefully you can see my first slide now. Is that a safe assumption?
Yeah, it's perfectly visible.
Excellent, thank you. Well, look, first of all, thank you very much to the Society and St. Stephen's College and all the people involved in inviting me. I'm delighted to be here. It would be much nicer to be there in person, but these things aren't always possible. Being there virtually is not as good, but it's okay. So we'll do our best with that. What I'm going to give you is what the screen says. I'm going to talk about paraconsistency, I'm going to talk about dialetheism, and I'm going to assume that even if you've heard the words before, you're not very familiar with what those are. Some of you may be, but presumably most people are not. So this is a very introductory lecture, and I want to try to explain what those two things are and possibly why one might be interested in them. So this is where we're going. The talk is in two halves. The first half is on paraconsistency. The second half is on dialetheism. They're connected, but they're different. I might break after the first section to see if there are any questions about that before we move on to the second half. So Arhant, we might break the discussion up into two sections, if that works for you guys.
Yeah, that's perfectly doable.
Okay, but we'll see how it goes. Look, we might not get through all of this, and if we don't, that's fine too. I'd rather go slowly and get some stuff well across rather than try to rush everything and get nothing across. So I'm not going to rush. Okay, so let's start with the first section, which is on paraconsistency. And let me start by giving you a definition of paraconsistency. So, all right. So paraconsistency is a term in logic. So we are going to be talking about some logic. I know not everybody is a logician, but I can't avoid some logic. Hopefully, I won't take for granted anything much that is not known by you guys. If it is, then I can always try to explain better. So you can always tell me, I don't understand that. Please tell me more. Okay? So here's the definition of paraconsistency, and it involves a principle of inference. It has a medieval Latin name, ex contradictione sequitur quodlibet, which means everything follows from a contradiction. Nowadays, it's usually called explosion, which is a sort of snappier name. An explosion is the following principle, that for any statements A and B, if A and not A, then B. In other words, everything follows from a contradiction. All right, that's the principle of explosion. And it's a highly counterintuitive principle. Here are two instances of it. The moon is round, the moon is not round. So slavery is legal in the United States. And explosion tells you that that inference is valid. Here's another example. The Buddha was born in 1900. The Buddha was not born in 1900. So water is made of hydrogen and oxygen. Now, prima facie, those things do not appear to be valid precisely because there's no apparent connection between the premises and the conclusion. So it may come as a surprise to those of people who've never studied modern logic before that the standard logic, so-called classical logic, tells us that that the explosion is valid. It's not as crazy as it sounds, and we'll see in due course why that's the case. But that's explosion in all its glory. It's called explosion because if your information is inconsistent, then it explodes and everything follows. So I've just referred to classical logic. It's worth remembering that this is a theory of what follows from what. And despite the name classical, it was invented only maybe 140 years ago by the German mathematician Gottlob Frege, and a little later by the British mathematician Bertrand Russell. So classical logic actually has nothing to do with any of the great classical societies of the world, India, China, Greece, Egypt. I'll come back to that in a little bit in a moment. Anyway, that's the principle of explosion. And as I've said, it's valid in, or taken to be valid in classical logic, which is the kind of orthodox logic of our day. So if you do a first course in logic pretty much anywhere in the world, you will learn classical logic or the rudiments of classical logic. So if you study logic at pretty much any university nowadays, you will be told that, despite appearances, explosion is valid. Okay. Now, a logic is paraconsistent if explosion is not valid. So that's the definition, finally, of a paraconsistent logic. And I shall tell you more about one simple example later on. But what's the point of a paraconsistent logic? Well, the term was coined by a Peruvian philosopher, a philosopher from Peru, Mira Casada, in 1976, which is about the year that the study of paraconsistent logic was beginning to take shape. And since 1976, there's been much investigation of paraconsistent logics, and there are many paraconsistent logics, and they're pretty well understood now, both their proof theories, their semantics, their algebras, and so on. So this is now a well-established part of modern mathematical logic. Okay, and What's the point of a paraconsistent logic? Well, the point of a paraconsistent logic is that you can have inconsistency without triviality. So triviality is a kind of technical term in this context. It means everything. So roughly, when you apply a paraconsistent logic to a theory, the theory can be inconsistent, but not everything follows. So inconsistency is kind of kept under control. It's localized. It doesn't spread everywhere as it would with classical logic if your information or your theory were inconsistent. Okay, so that's the definition of paraconsistent logic and roughly why people find it interesting. Let me now talk about a brief history of paraconsistent logic. The fact that explosion is valid in classical logic might give you the impression that it's a very old principle in formal logic. It's not. It's actually, in historical terms, a relatively recent principle of inference. Let me just explain why. So, the earliest system of formal logic that we have, I'm sure, as you know, is due to Aristotle. Aristotle gave us a theory of inference called syllogistic, which many of you will have met before. And syllogistic is actually paraconsistent. So, look, here's a syllogistic inference. No S or M, some M are S, so all S are S. Now that's in syllogistic form, and it's not a valid syllogism. So there's an invalid inference from a contradiction. So contradictions do not imply everything in syllogistic. Now, Aristotle was well aware of this. He actually points this out. He tells us in the Analytic that syllogistic is paraconsistent. Of course, he doesn't use those terms because those are modern terms, but he's quite clear that contradictions don't imply everything. So the oldest system of formal logic is actually paraconsistent. Okay. So you might ask, well, where did paraconsistency come from in the history of Western logic? Indian logic is a different issue, and I'm not going to talk much about that. But as far as I know, there's no history of endorsing explosion in Indian philosophy. That may just be ignorance on my part, and you can tell me if I'm wrong. But let's stick to Western logic for the moment. Where did the principle of explosion come from in Western logic? Well, as far as we know, it first appears in early Latin logic. So this is logic in the European Middle Ages. And we think it's due to a logician working in Paris in the 12th century whose name was William of Soissons. Certainly after this period, the principle of explosion is well known in medieval logic, but it's contentious. Some people endorse it, some people don't. But what William did was invent an argument, which is now a very well-known argument, but it's not usually attributed just William because people don't know a lot of the history of logic in the West. So what he did was invent an argument for explosion. Sometimes in history, this is called William's machine. And here it is. So suppose that A and not A, those are the premises. Since not A, then not A or B, because that's just disjunction introduction. And from A and not A or B, B follows. So we've assumed A, we've assumed not A, and we've inferred B. Okay, and that last inference is called the disjunctive syllogism. From A and not A or B, you can infer B. So what this shows is if you assume disjunctive syllogism and or introduction, that's this step, then you've got explosion. Now, both those inferences, the disjunctive syllogism and disjunction introduction, are kind of debated in medieval logic. As I said, there's really no consensus on whether those principles of inference are valid. It's complex. We can talk about that more if you want, but let's pass on for the moment. So, when did explosion become entrenched into formal logic? Well, after medieval logic, most of the wealth of medieval logic was forgotten, and the standard logic reverts to being syllogistic. So it's not orthodox in modern logic until the invention of classical logic by Frege and Russell and company. And the system of logic they invented was called classical logic, and it was so much more powerful than anything that had gone before that it soon became orthodox. And explosion is valid in classical logic, as I said. So explosion comes orthodox in logic around the beginning of the 20th century. As I said, it's rather late in the history of Western logic. Okay. Classical logic was invented by mathematicians, and it was really invented by mathematicians applying the tools of mathematics to logic. And that couldn't really have been done before, because the mathematics you need was really developed in the 19th century. Things like axiomatics, model theory, algebraic structures, combinatorics. These are all developments really of the 19th or late 18th centuries. And those are the mathematical tools you need if you're going to apply them to logic. So Frege and Russell applied these tools and came up with classical logic. But classical logic has problems, and it's always had problems, and logicians know this. And so almost as soon as classical logic had been invented, logicians were invented systems of logic which are usually called non-classical. And there are many, many of those. And they've been extensively investigated in the 20th century, and they continue to be investigated now. Paraconsistent logic is one of those. And investigations of paraconsistent logic started around the 1970s. I told you the word paraconsistent was coined in the 1970s. And there are many different systems of paraconsistent logic. Let me just give you a few of the people who were instrumental in the early years of paraconsistency. Okay, I won't tell you. Each of their systems of paraconsistent logic was motivated by a certain approach. I'm not going to go into those, except to point out that they're very, very different. So there are many paraconsistent logics, and they work on different principles. And just to tell you who some of the early people were, one of the first people to investigate paraconsistent logic was Stanisław Jaśkowski in Poland in 1948. Another early investigator was Søren Haldane in Sweden in 1949. Yet another approach was developed by Newton da Costa in Brazil in 1963. And yet another approach was invented by the Australian logicians Richard Ratley, who changed his name to Silver, and his wife at one time, Val Ratley, who changed her name to Plumwood. And their work goes back to the early 1970s. Now, the slides show what sort of approach they had. I'm not going to go into those. But what I want you to note is that it was invented by people working in very different countries, indeed very different continents. And they were all pretty much unaware of each other. So these approaches were developed independently. Sometimes in the history of science, you get simultaneous inventions of something by people working independently. The history of the infinitesimal calculus is a good example of that. But when that happens, it's kind of a sign that the time for the idea has come of age, or has come. And so this period really, and the fact that paraconsistent logic was invented by so many people independently, shows that at that time, the time for paraconsistent logic had come. Okay. So since that period, paraconsistent logic has been logics have been invented quite a lot, and they're now a standard part of modern mathematical logic. Even they have their own category in the American Mathematical Society categories of areas of logic, for example. Okay, so that's a bit about the history. Now, I'm assuming that most of you will have never met a formal paraconsistent logic before. So what I thought I would do next is give you an idea of one formal logic, one formal paraconsistent logic. And this is very easy to explain because it's essentially classical logic with a very, very small tweak. So if you know classical proposition logic, you won't have too much trouble understanding this paraconsistent logic. So let me tell you what classical proposition logic is. You may not have seen it in exactly this form before because it has many presentations, but this is one very standard presentation. So I'm going to talk about the semantics of classical logic. And in the semantics, or the model theory, if you want to use a logical term, there are interpretations of the propositional language, and every interpretation divides all the formulas up into two kinds, the truths and the falses. There's a picture. And the truths and the falses are disjoint and exclusive. So every sentence is either true or false, not both, not neither. So if you study classical logic, you'll be told that truth and falsity are exclusive and exhaustive. You won't be given a rationale for that, probably. You'll just be told that that's how things are. And this is a fundamental assumption of classical logic. Okay. So an interpretation divides all the formulas into the truths and the falses. And now you want to know how the complex formulas depend on their parts. And these are the truth conditions for negation. Sometimes you'll see these in the form of a diagram or a matrix, but what they encode is the idea that not A is true just if A is false, and not A is false if A is true. Now, given that truth and falsity are exclusive and exhaustive, you don't really need the second clause because it follows from the first. But I'm giving you both for reasons that will become clear in a moment. So those are the truth and falsity conditions for negation, and the truth and falsity conditions for conjunction and disjunction are the standard ones. So a disjunction is true in a situation or an interpretation if one or other of A and B is true, and it's false if both are false, and dually for conjunction. Okay, so those are the standard truth and falsity conditions for negation, disjunction, and conjunction. You can define other connectives in terms of those if you want. Lastly, the definition of validity. When is an inference valid? Okay, well, it's actually easier to define invalidity. So an inference is invalid if there's an interpretation where all the premises are true and the conclusion is not. Notice that I don't say the conclusion is false, I say the conclusion is not true, right? Of course, if truth and falsity are exclusive and exhaustive, that comes to the same thing. But that's not quite the form I'm giving you the definition. An inference is invalid if there's an interpretation where all the premises are true and the conclusion is not. Okay. An inference is valid otherwise. All right. Now, given these things, you can see why explosion is valid. It's valid vacuously because there can never be an interpretation where the premises are both true. Because you're in this situation. So if A is true, its negation is false, and if A is false, its negation is true. So there's no interpretation where the premises of an instance of explosion can both be true. A fortiori, there's no interpretation where both premises are true and the conclusion isn't. So as logicians sometimes say, explosion is vacuously valid just because the premises can never be true. That's why explosion is valid in classical logic. Okay, so much for classical logic. Now, I'm going to tell you a very simple paraconsistent logic, which is essentially the same as this. There is one small tweak. And what you do is this. In classical logic, truth and falsity are exclusive and exhaustive. Now, we're going to get rid of that assumption and suppose that truth and falsity may be neither exclusive nor exhaustive. So this is a logic called first degree entailment. Don't worry about the name, doesn't matter in this context. And you can see the truths are the blue vertical left-hand side of the diagram. The falsities are the bottom half of the diagram. So in the purple overlap, things are both true and false. In the top right quadrant, the plain quadrant, things are neither true nor false. In the top left quadrant, things are true and true only. In the bottom right quadrant, things are false and false only. So there are 4 possibilities. Okay, so what we've got rid of is the assumption that's made explicitly, without usually commenting on this fact, that truth and falsity are exclusive and exhaustive. Now, that is the only change you need to make to the machinery I've given you. So the truth conditions for negation, for conjunction, and for disjunction are exactly the ones I gave you. The definition of validity is exactly the one I gave you. So we've changed nothing except that initial assumption that truth and falsity are exclusive and exhaustive. Now, warning, in classical logic, to be false is the same as not being true. And if you've done some logic, you'll think in those terms. Now, that assumption no longer holds because the false things are these guys in the bottom half. The things that are not true are these guys. And you can see the falsities are different from the untrue guys. That's why I said I've given you the definition of validity in terms of untruth, not falsity. Okay. So you can see why now explosion is invalid, because just consider an interpretation where A is true only, C is both true and false, and B is false only. Then C and not C are both true. They're false as well, but they're true. And B is not true. So that's a counter model. It shows you that explosion is invalid. That's why this is a paraconsistent logic. And if you want to play with it, you'll see that the disjunctive syllogism is invalid as well for similar reasons. We won't go through the details. All right. Now, that's the definition of one very well-known, very simple paraconsistent logic. The next question is, well, what inferences does this validate and what inferences does this invalidate? Let me give you a very simple proof theory. For those of you who don't like sort of lots of symbols, close your eyes, it doesn't matter. But for those of you who know what a natural deduction system is, let me give you a natural deduction system, first of all for classical logic, and I'll tell you then how we modify it. So this is a natural deduction system in Probit style. Premises are above the line, conclusions are below the line. So those are the introduction and elimination rules for conjunction. Those are the elimination and introduction rules for disjunction. If you've never seen this kind of thing before, don't worry too much if you don't understand all the details. And then we have rules for which for negation. which are these, and the double bar means that the inference goes both ways. So this is double negation in both directions. These are De Morgan laws in both directions. And then you've got these two guys, excluding middle and explosion. All right. If you see a natural deduction system for classical logic, it's not usually that form. I put it in that form for a very simple reason. Because if you want to get a natural deduction system for first degree entailment, all you do is delete the last two rules. Because it's this rule which tells you that everything is either true or false, and it's this rule which tells you that nothing is both true and false. So you can see that first degree entailment is weaker than classical logic, but it's the same as classical logic minus excluding middle and explosion. All right. So I said I wasn't going to say much about Indian logic, but let me just make one comment before we pass on. You've seen this picture already, and you've seen that there are four possibilities. Something can be true and true only, false and false only, both or neither. Now, in Indian metaphysics, there's a principle of metaphysics or logic, not sure what you call it, that goes back to a long way. It's called the Chatushkoti, as you may know, which means in Sanskrit, which I don't speak, but it means something like four corners, 4 points. And this is a very ancient principle of logic. It's in play in Indian philosophy at the time of the historical Buddha. So we're talking, well, 5th, maybe 6th century BCE. And we know it's in play at that time because it's employed in a number of the Buddhist sutras. So it's quite explicit in some of these sutras that every statement is one of true and true only, false and false only, both true and false, neither true nor false. So this system of first degree entailment is actually, in some sense, very familiar in Indian logic because the Chatushkoti is itself very familiar. Of course, the people who invented first degree entailment didn't know anything about the Chatushkoti. They didn't know anything about an Indian logic. And the people who were developing the Chatushkoti didn't know anything about modern logic either. So there's no sort of historical connection here, but it's kind of interesting that the ideas behind this particular paraconsistent logic were implicit in early Indian philosophy. Okay. That's all I'm going to say about Indian philosophy. We can talk more about that if you want to. All right. Now, I'm going to break at the end of the section on paraconsistency, but before I do that, let's do one more thing and talk about some possible applications of paraconsistency, just to give you an idea of why you might be interested in this. And you might be interested in it because it quarantines contradictions so they don't explode. And there are many possible applications of that. So modern data processing uses information in a database, but it doesn't just store information, it draws consequences, inferences from that information. And information in a database may be corrupt, and it may be corrupt because an error has been made in entering the data. It may be corrupt because it's come from different sources and the sources disagree with each other. So look, you might well have a database which says the next train from Delhi to Calcutta leaves at noon today. But another bit of your information says there's no train from Delhi to Calcutta today. Okay, the database is corrupt. There's no algorithm for determining when information is inconsistent. You might be stuck with this. But look, if that's your information, you do not want your inference engine to infer the next train from Delhi to Mumbai leaves at 1400. That would be silly, right? So if you're using a logic to make inferences from a possibly corrupt database, you're going to want it to be paraconsistent. And inference engines that are used in databases normally are. Okay, so that's one possible application of a paraconsistent logic. Here's another one. Look, in the history of philosophy, a number of philosophers have produced theories which are inconsistent, sometimes inadvertently, accidentally, but one exception to that is Hegel, who produced a theory of philosophy which was explicitly inconsistent. He tells us this. Okay, Hegel exegesis is a contentious matter. You might want to argue about this, but let me give you some quotes. So Hegel says this: ordinary experience itself declares that at least there are a number of contradictory things about, contradictory arrangements and so forth. The contradictions being present in them are not merely in external reflection. So they're not in thought, they're in reality. Okay, this is a quotation from the Lesser Logic, by the way. And then he goes on to say, external sensible motion is itself contradiction's immediate existence. Something moves not because it's here at one point of time and there at another, but because at one and the same point of time, it is here and not here. And this here both is and is not. We must grant the old dialecticians the contradictions which they prove in motion. But what follows is not that there's no motion, but rather that motion is existent contradiction itself. So look, he's clearly he's clearly giving you an inconsistent theory of motion. To be in motion is to be, a thing is in motion if it's both at a point and not at a point, here and not here, at the very same time. Why might he think that? Well, we might come back to that when I talk about dialetheism. But clearly, whatever theory of inference Hegel was working with, it must have been paraconsistent. It was maybe syllogistic or some variation of that. We can talk about that if you want. But you need a paraconsistent logic if you're going to take seriously Hegel's theories and similar inconsistent philosophical theories. I'm not telling you Hegel's theory is true, but if you want to take it seriously and understand it, you've got to use a paraconsistent logic. All right. And you might say, well, okay, yeah, that's philosophy. Well, let's get serious. What about science? Well, inconsistent theories have been used in the history of science itself. Let me give you a very famous one, which is Bohr's theory of the atom. So you may know what this is. It was a model of the atom, just the hydrogen atom, proposed by Bohr in the late teens, 1920s. And sometimes it's called the solar system model. Because if you take the hydrogen atom, it has a central nucleus, which is a proton, and that has an electron, which is circling it. So it looks a bit like the solar system. So this is Bohr's theory of the atom. Now, there are problems with this because the electron is accelerating. Now, if you've never studied dynamics, it won't be clear that it's accelerating, but it's going around in a circle. And things move in a straight line unless there's some force acting on them. And if some force acts on them, they're accelerating. So this electron is accelerating. What of it? Well, standard electrodynamics tells us that if an electrically charged particle is accelerating, it radiates energy. So here's the electron. It's going around the nucleus, and it's accelerating, so it's going to radiate energy. And if it loses energy, it's going to spiral in and crash into the nucleus. Okay, so on this model, if you put together the Bohr theory of the atom and standard classical electrodynamics, matter is unstable. Okay, what did Bohr say about this? He said that you've got to impose the quantum principle. Namely, energy does not come in discrete, it's not continuous, it comes in discrete quantities. And so if you've got an electron going around in a circle, it doesn't radiate, okay? The only time it radiates is if it jumps in orbit, which is closer or further apart. So if this electron jumps to a closer orbit, then it will radiate energy, but not otherwise. So energy that isn't continuous. It comes in quanta, discrete chunks. What's the problem with that? Well, the whole theory depends on classical electrodynamics, because you need that to figure out how much energy will be radiated when you make a quantum jump. So the Bohr theory of the atom was inconsistent with classical electrodynamics, which you needed. So the Bohr theory of the atom was inconsistent. And Bohr knew this. He pointed this out. So here's a really important theory in the history of science, which was inconsistent and known to be inconsistent. Bohr must have been using a paraconsistent inference engine. Which one? Well, he wasn't a logician, so he didn't tell us. The Bohr theory of the atom didn't last very long. It was junked 5 or 10 years later, not because it was inconsistent, but because it gave the wrong predictions when you went to the next most complex atom, which is helium. All right. So inconsistent theories are known in the history of philosophy and the history of science. Let me give you one more example, and then we'll break for a discussion about paraconsistency. We now know that there's such a thing as inconsistent mathematics. So we know that there are mathematical theories which are based on paraconsistent logics. There are paraconsistent set theories, paraconsistent topologies, paraconsistent algebras. Let me give you a very simple example. This is actually a topology. So we've got a straight line. We break it into a left half L and a right half R. And there's a point of division, which is P. P is a boundary. And boundaries are curious objects. But it might well be that this boundary is symmetric. And if the boundary is symmetric, it looks as though it's going to be in both left and right. So P might have the following properties. If a point X is less than or equal to P, up here, then it's in left but not right. If it's in right, so P is less than X, it's in right and left. So if it's on the boundary, it's in both left and right, and not in left and not in right. It's inconsistent. And you might want to say, oh yeah, well, that's not very interesting. But it actually has a very interesting application in the mathematics of impossible pictures. So take this inconsistent picture. Look at it. It's inconsistent. It's an impossible picture. Why is it impossible? Well, it's impossible because the face has an inconsistent property. So this face, okay, is horizontal. This face is vertical. So this line which joins them is both horizontal and vertical. So this is a boundary between these two surfaces, and it has inconsistent properties. It's an inconsistent boundary. Yet, obviously, lots of parts of the diagram, or rather the configuration, are consistent. I mean, this face is simply horizontal. There's nothing vertical about it. So if you want to describe the topology of this shape, you need the kind of inconsistent topology I was talking about, where parts of it, certain boundaries, can be inconsistent. All right. Now, so far I've just been through the first half of this talk, which is about paraconsistency. If we don't get any further than that, that's fine. You've at least learned something about paraconsistency. So let's break there. Maybe I'll carry on with the second half, maybe I won't. That'll be up to you guys. Let's see if you have any questions. So, will you chair this, please?
Yeah. Yeah. So, if anyone has any questions, please ask. Or okay, till then, I have a question, or like, is something I want to understand. This is regarding when you talked about Hegel. So while I don't understand Hegel very, very well, I believe what he does is, like, he bases his entire metaphysics on contradiction by sort of ontologizing contradiction at some level. Like, he is not really like, I think what's key for him were the Kantian antinomies, where
Yes.
while Kant locates, like, the contradictions in the antinomies, their antinomic nature, in, like, the inability of reason to grasp, like, such things, and so on. Whereas what Hegel does is that he reverses that and says that the contradictions at hand in the Kantian antinomies are revealing some ontological tensions in reality itself. So
Yeah, I think that's right.
yeah. So I believe, like, Hegelians, they when speaking about the principle of non-contradiction, just say that he follows the principle until it breaks down. That's just how his general method of dialectic goes as well. He just follows things through. That's his method. And I want you to comment on that ontologization that he does, because even his principle of identity is very interesting. I've seen it described as a principle of identity and difference. That's his principle of identity. And I want you to comment on, like, their ontologization, because what I believe a Hegelian would say is that, like, yes, what a paraconsistent logic would do is that it locally within still, I believe, a classical logical framework accepts contradiction. That's what I've been able to get from paraconsistency. Whereas for Hegel, it is like ontological and, of course, like, dynamic at a certain level. There's like a self-mediating movement, like Aufhebung, as Hegel calls it. So I want you to, like, perhaps comment on that
Sure.
self-mediating movement. Yeah, thank you.
Okay. Look, what you say about Hegel is right, essentially. And what you say about some traditional Hegel exegetes is also right. They don't take Hegel to be endorsing contradictions. Okay. Now, first of all, where the real action is in Hegel is in the dialectic. And I haven't spoken about the dialectic at all. Let me come back to that in due course. All I've been saying so far is that Hegel endorsed contradictions. And that's explicit in the text that I gave you. He gives you a theory of motion, okay? And his theory of motion is inconsistent. Now, that is kind of related to the dialectic, but it's independent of it. Essentially, it's his solution to Zeno's arrow paradox. We might come back to that if I talk about dialetheism. But there's nothing in his account of motion, which those quotes were drawn from the lesser logic, but he says more about it in the logic. But he doesn't say, well, here's a theory of motion that breaks down. He says, this is what it is to move, right? And I'll tell you what it is to move. It's to be contradictory. So he does not endorse the principle of non-contradiction, obviously. Right. Now, let's come back to Hegel exegetes. It's very common amongst Hegel exegetes, especially in the Anglosphere, to say that he doesn't really introduce contradictions because, after all, in the dialectic, they're resolved. Okay. And they say that because they think that the principle of non-contradiction is obviously true. And if Hegel is your favorite philosopher, you don't want to land on them something which many philosophers think is crazy. So a lot of, especially Anglo-Hegel exegetes, have said that Hegel's not really a dialetheist, doesn't really endorse contradictions. Now, that is changing, as a matter of fact, because there are several modern Hegel exegetes, including Greg Moss, Suresh, who are capable of reading Hegel, okay, without preconceptions. And they have paraconsistent interpretations of Hegel. Now, when the consistent exegetes of Hegel say that contradictions disappear, that's pretty obviously a misunderstanding of Hegel, because in the dialectic, you've got a sequence of triads, thesis, antithesis, and resolution, to use Fichte terminology. And the third stage of each triad, in the third stage, the contradiction is aufgehoben. The verb in German is aufheben, which means in German it has contradictory meanings. It means both gotten rid of and preserved. Now, how to understand that is the crux of how you understand Hegel's dialectic. But it does not mean that you get rid of it. The contradiction is preserved. It's still there. Now, what that means, we can argue about, but the contradiction does not disappear in the third stage of the dialectic precisely because it is preserved. And Hegel revels in this fact because he's found a German word which does exactly what he wants, to explain a word which tells you that the contradiction is both gotten rid of and not gotten rid of. Is that a contradiction? Yes, of course it is. But then, Hegel liked contradictions. So I'm sorry, that's been a rather long answer to your question, but that's, I think, what the case is.
All right, thank you very much. We have three questions. One is from the chat. It's from Chatishkoti, and there's Eric Snyder and Suresh raising their hands. I believe Suresh is going to ask about Hegel, and since we are on that subject, we can take his question first. So please go ahead.
Okay. Yeah, thank you. You were absolutely right. It was on Hegel. So yeah. It's a pretty simple question. I mean, so one thing is, of course, Hegel is of course he's endorsing contradiction in some ways. The only thing that I would add in that when we say that Hegel is endorsing contradiction, it might come off as if he is in opposition to the law of non-contradiction. He is just endorsing his law of he's endorsing that principle rather than denying it. But that is not
how is this possible?
What?
How can he endorse the contradiction and deny the law of non-contradiction? Oh, how can he endorse the contradiction and endorse the law of non-contradiction? To do that is itself contradictory.
No, my point was something else. My point was that he does not, in the logic at least, he does not have this. He does not take this either affirm or deny this principle of non-contradiction. Rather, he derives it immanently from in his logic. So that was just a side that he does not have a presupposition of law of non-contradiction either in its denial or affirmation. So that's just one point. But my question was that and of course his logic is simultaneously also ontological, but it seems to me that in paraconsistent logic it has some sort of formalism to it, which one would like to think that it's not there in Hegel. And there is a certain, as Arihant also said, that there is a certain kind of self-movement, dynamicity, and all of those things. So I was just wondering what's the difference, if any, do you see between dialectic or dialectical logic and paraconsistent logic as you presented here today, or do you think there are no differences? Or
Okay, look, to the extent that Hegel has a formal logic, it's syllogistic, okay? But of course, he thinks that applies only to things which are motionless. Once things change, you've got to admit contradiction somehow. Now, he does not give a formal logic for that. Neither could he have done, because he didn't have the mathematical tools to do this. I mean, he knew quite a lot of mathematics. He discusses a lot of mathematics in the logic, but he doesn't have the tools of modern logic. So of course he doesn't give a modern paraconsistent logic. So I'm not telling you that he endorsed any modern theory of paraconsistent logic. That would be anachronistic. Now, you can argue about which of the modern paraconsistent logics would have suited his purpose, and modern commentators who know their formal logic and Hegel disagree about this. So I'm not going to go into that now, but there is an issue there. I mean, clearly, Hegel does not deploy explosion.
Certainly. Determinate
must be
negations
using-
are the more accurate.
So he must be using some kind of paraconsistent logic. What? Well, that's something that modern Hegel commentators can argue about.
Okay, sure. Okay,
Yeah.
that helps. I mean, people.
Okay, thank you, Suresh. Next, we can take the question from Eric Snyder, please. Yeah, go ahead.
Hi, Graham.
Hi.
So you've pointed out some that paraconsistent logics have some nice applications, and suggested that certain classically valid rules of inference may be problematic. They don't track relevance very well. And I realize the point of this talk is not to make a normative case for one logic over another, but I suspect in a different kind of talk you would maybe make that case for a certain logic of a paradox or something like that being perhaps better than the other available logics. And so, I mean,
your suspicions are correct.
So it clearly that would go beyond just applications, right? Because all of the logics are going to find applications. So just curious, what do we need beyond the mere applications of paraconsistent logics to make the case that this one is in some sense better than the other available options?
Yeah, that's a good question. As you know, the second part of the 20th century in particular has seen the development of many non-classical logics. And the pages of logic journals are full of debates about which logic is right. There are even now people who think that that question doesn't even make any sense, because they think that there's a pluralism about logic. So it doesn't even make sense to ask which is right. I think that debate is itself confused, but it's without doubt that there are many systems of logic. One of them is classical and most of them are non-classical. And then you have to ask yourself, which is the right theory of logic? Okay. And as I said, the debates of logic journals are full of discussions about that. I think how you go about addressing that question is as follows. A theory of logic that you'll find in the pages of a textbook, for example, tells you, is a theory about what follows from what and why.
Yeah.
Okay. And what we're doing in choosing the best theory is what we do whenever we choose the best theory about something. So we theorize in physics, we theorize in ethics, we theorize in metaphysics, we theorize in logic. How do you choose the best theory? Well, there are standard criteria for this in the philosophy of science. First of all, you want a theory which does a reasonable amount of justice. The data on its own, that's not usually good enough. Then you need a bunch of other criteria like simplicity, power, the refusal to use ad hoc hypothesis, and so on. And in some sense, when we choose a theory in science, we choose the one which works best on this bundle of theories. Okay, that's vague. You can make it more precise, but that's the rough idea. And when we choose a theory in logic, we use exactly the same methodology for theory choice as we do in, say, physics or metaphysics. We choose the theory which is overall best. Okay, that's going to be a fallible choice because new theories tend to come along. But that's what we do. And so that's the rough methodology. That is usually called anti-exceptionalism now. That's a term coined by Tim Williamson. I don't like that term. I prefer abductivism, which I think is better. But I think that when you apply the methodology, a paraconsistent logic comes out on top. Tim thinks that when you apply the methodology, classical logic comes out on top. We disagree about that. But to do that, we'd have to argue about how the various theories perform on the various criteria for various things. Okay, that's too big a thing to go into here. But let me just point out that at least Tim and I agree on the methodology, and that's the way I think that one should go about answering your question. I don't know if that says enough to indicate what I have in mind.
Yeah, is it safe to say that you think that some version of paraconsistent logic gives us a better account of what follows from what or logical consequence than other versions of logic? Yeah.
Yes.
Thanks.
That doesn't mean that I think I think that classical logic is globally wrong. So I think you need a logic which accommodates truth value gluts, maybe truth value gaps, but certainly gluts. But that doesn't mean that you can't use classical logic. You can use it for what it was designed for, namely to apply in consistent, complete situations. And this is not a new idea. Take intuitionist logic, for example. Intuitionistic logic excluded middle fails. But an intuitionistic logic will tell you you can use excluded middle in certain contexts, namely those which are decidable or finite. But that doesn't mean that intuitionist logic is not correct. Doesn't mean that you've got a pluralism here. It just means that you've got a general theory, but you can use a restrictive theory in certain contexts because of what you might call contingent features of the situations you're dealing with. And that's what I've just been talking about with regards paraconsistency.
Thanks.
All right. We first have a question from the chat box, and it's by Lokesh Jindal. I'll read out the... Oh, wait.
I can say it. I can say it. You don't have to. Yeah.
Sure. Lokesh, go ahead.
So, Professor Graham, thank you for being here. I've read your papers on Chatushkoti and your book also, partly. And one thing that I've been wondering, I've been a student of Buddhist philosophy for some time now. And one of the things that you say is very intriguing, that that these Chatushkoti, or the four corners, could be explained in terms of paralogics or paraconsistency in these things. But when you study Buddhist philosophy, for example, Acharya Chandrakirti, who draws heavily from Arya-Nagarjuna, those texts, you'd see that they would kind of reject the third one on the basis of the first and second, right? So either production is from self or from other. So self, let's say, is A, and the other is minus A, and then the production from both. So production of both part is rejected because production from A, production of self, is rejected, right? So these are not independent in that sense, right? But when I see your presentation, the four boxes, the true and false, it seems like these four are kind of standalone, kind of living on their own life, and can be combined together to form different kind of, higher order kind of assertions. So I'm just wanting to understand, do you think that these four are kind of independent in your modern paralogics, or are they kind of dependent on each other, so that the first two are really the true ones and the third, fourth, etc. are kind of driven from them? What would you say on to that?
Okay. My own view is that when you see the Chatushkoti deployed, what's actually going on is something like first degree entailment. So there really are those four quadrants, right?
Yeah.
Now, interpretations of Buddhist philosophy are always going to be contentious. So I know that what I've just said is contentious. So let me just say a few things further. The first is this: Buddhist philosophy has been evolving now for 2,500 years. And there are many different Buddhist metaphysics, logics, even in India, let alone once Buddhism goes into China. So it would be wrong to say that there's a uniform view about Buddhist metaphysics. There isn't. The Buddhist metaphysics depends upon the school you're coming from, although there are certain commonalities, that's for sure. Now, the origin of the Chatushkoti goes back to the period of the Buddha himself. And I don't think there's any sense in which the Buddha rejects any of those four possibilities. So in the sutras, the Chattoskoti is deployed explicitly in several of them. In one of them, there's an interlocutor. Their name is Vatya. I've never been sure exactly how to pronounce it. But the interlocutor, Vatya, asks the Buddha, if you take someone who's achieved enlightenment, what happens to them when they're dead? Do they exist? And the Buddha says, well, I'm not going to tell you that. Does he not exist? Well, I'm not going to tell you that. Does he both exist and not exist? No, I'm not going to tell you that. Does he neither exist nor not exist? Well, I'm not going to tell you that. Okay, so there's a question about why the Buddha refuses to answer. That's another story. But notice that the Buddha does not say, don't be silly, Vatya. How can something be both true and false? That's not the move. So the Buddha is quite, seems to be accepting the possibility that things can be both true and false. Okay, so I don't know that there's much to argue about in the early Buddhism. Now, as Buddhist philosophy evolves, it gets more complicated. And there are certainly Buddhist philosophers who endorse the principle of non-contradiction. The most obvious examples are Dignaga and Dharmakirti in the 5th century. They're pretty explicit about this, but they've been in debate with the Nyaya about this, and the Nyaya certainly accept the principle of non-contradiction, and the Nyaya win that argument. Okay, last thing. You talked about Chandrakirti, who actually plays very little role in Indian philosophy. He plays an enormous role in Tibetan philosophy. And there are passages where Chandrakirti rejects a contradiction. But he only rejects particular cases of contradictions. He never says contradictions can never be true. He says that contradiction can't be true. Okay, now that is consistent with holding that some contradictions are true. What? Well, that's an interesting question. And then we have to worry about lots more things in Buddhist philosophy. But lots of contemporary exegetes of Madhyamaka, of course, Nagarjuna and Chandrakirti were Madhyamaka, but lots of common Anglo-exegetes take Chandrakirti to be like Dignaga and Dharmakirti on the basis of things he says, like, you can't have that contradiction. Mark Sideritz is one such person. I think that's just insufficient ground, because to reject one contradiction is not to endorse the law of non-contradiction. The law of non-contradiction says that no contradictions can be true, not that every contradiction cannot be true. So, sorry, I've said a lot in answer to your question. I don't know if you want to come back at this.
Well, no, I got my answer. Thank you very much. I think my more worry was whether the third follows from first and second, or whether third can stand on its own as a possibility while rejecting first and second, first or second.
Yeah, so look, there's an interesting question here. When you see phrases of the Chattoskoti, the first koti is just said as truth, and the second as falsity, or actually existence and non-existence, usually.
Right.
But to make sense of the dialogue, you really have to assume that when they say true, they mean true and true only. And when they say false, they say false and false only. And Nagarjuna usually interprets it that way.
Right.
I think to understand what's going on in both the Buddhist dialogues, the sutras themselves, and in Nagarjuna, you have to interpret the first and second kotis as true and true only, false and false only, in which case the first, second, third, and fourth are independent of each other.
Right. Yeah, I think that you mentioned that in your papers and in the book too. Yeah. Well, anyway, I should not take more of time. I think other people have questions. So thank you very much, Graham. Thank you.
You're welcome.
Thank you, Lokesh, for your question. That was very interesting. And next we have Vishal. Please go ahead and ask your question.
Hi, Professor. This is
Hello.
Vishal. I hope you can see me. Thank you for this introduction to paralogic. And while you were narrating this history of the development, I what caught my mind was this Newton de Costa's maxim that negation is not truth functional. And
Yes.
I've been thinking about it since that time. And
Yes.
what I was thinking about is is there the possibility that the difference between paralogic and classical logic developed by Frege and Russell as mathematicians boil down to different metaphysics of negation as a logical operator. And is that difference, or is that metaphysics of negation equivalent or identical to metaphysics of nothingness? This question, the last part was prompted by your discussion with Robinson's about the metaphysics of nothingness that I was just hearing a couple of weeks back. So that's my question. Thank you.
Okay. All right. So let's take this slowly. Newton de Costa was one of the first people who propounded a paraconsistent logic. Absolutely right. Paraconsistent logics work on many different, there are many different kinds. And the one that Newton produced worked on a certain principle, which is, as you say, the non-truth functionality of negation. So once you know that the value of A, you don't yet know the value of not A. It could be true. Suppose that A is true. Not A could be true or false. It's not yet determined. So these semantics are now known as non-deterministic semantics. So Newton proposed systems of paraconsistency based on non-deterministic semantics of negation. The one that I gave you works quite differently. In that system, negation is truth functional, right? If A is true, not A is false. If A is false, not A is true. So once you know the truth values of A, you know the truth values of the negation. Okay, so certainly different paraconsistent logics have different views about negation. Okay, now, are those differences semantic or metaphysical? And how do you draw the distinction? Because it's not obvious. I think that it's very hard to answer that question because in one sense it's semantic, it's one sense it's metaphysical, because those two issues overlap. I mean, truth is partly determined by meaning and partly determined by the meanings of the things we say, and it's partly determined by reality. So consider the sentence, Melbourne is in Australia. That's true. What makes it true? Well, one of the things that makes it true is the meaning of the words Australia and Melbourne. And another thing that makes it true is some facts about the geography of a large island in the Southern Hemisphere. So truth is partly determined by semantics, partly determined by metaphysics. And the different paraconsistent logics have different views about negation. And I think you can hear those as semantic or metaphysical. There's a lot more to argue about there. Okay, that's the differences between different kinds of paraconsistent logicians. But your question was explicitly about paraconsistent logic and classical logic. Now, exactly the same issues are going to arise there. And in some sense, there's got to be, let's just focus on first degree entanglement, the system I gave you, and classical logic for a moment. There's certainly disagreement. The disagreement there is not so much about negation, because classical logicians and paraconsistent logicians give the same truth and falsity conditions for negation. That's not where the difference is. The difference is on whether truth and falsity are exclusive and or exhaustive. That's where the difference is. Now, Is that difference semantic or is it metaphysical? Well, as I've just explained, it's probably both. Or at least if you want to argue about that, you've got to get more precise about semantics and metaphysics. And of course, you can do that, and some people do. But that's roughly the answer to your question. Do you want to come back at that?
So the second part of my question was this metaphysics of negation. Do you think it is equivalent or identical to the metaphysics of nothingness?
Oh,
yeah.
No, those are different issues. They're connected because I don't think you can give an adequate account of nothingness without using a paraconsistent logic, which is going to involve, a view about how you handle negation. That's true. But nothingness is its own tricky issue. And if you want to discuss nothingness, the first thing you've got to do is say what you're talking about. And that's a tricky issue. But that's a tricky issue that arises if you're talking about nothingness. That's not an issue that arises when you're talking about negation or paraconsistent logic. That's a whole separate debate.
Yes, thank you. Thank you for your answer. Really appreciate it.
You're welcome.
Next, we have Yagyapal. Please go ahead.
Am I audible?
Hi, Kabal.
Am I audible?
Yes.
Quickly.
First of all, it's really great having a lecture from you. We've all people of DU have studied your textbook for non-classical logic, so it's really nice to see you give a talk. So I have 3 questions, very small ones. One is continuing the conversation you were having with Eric. So you and Williamson both disagree on the way that you think about logic, right? He is abductivizing for classical logic, and you. So are you? My question is: are you both? Because both of your methodologies are abductive. So what is the exact thing that you are disagreeing on? Is it just the notion of logical consequence that you guys disagree on?
That's a consequence of, but we both agree on the methodology of how you choose the right theory.
Yeah.
But he thinks that when you apply that methodology, you get classical logic. And I think that when you apply that methodology, you don't. So that's the difference between us. And as a result,
logic have you ended up on? If you have ended up on anything.
I think probably the right logic is some extension of LP, or maybe first degree entailment.
Okay.
I think there's many debates that are to be had there about the nature of the conditional, modality, lots of other things. Okay, so I think that the right answer is still open to a certain extent. But what I do think is that it's got to be paraconsistent, whereas Tim thinks it's got to be classical. Now, he and I have argued about this a lot in print, why we go different ways. And I can't really go into all the things here, but
I think maybe I'll actually go through the writings in print first, and then maybe write to you about this.
Yeah, okay. Look, if you want to email me, I'll send you some references. But roughly speaking, he thinks that classical logic is very successful because it's the logic of science and
predictive power. It helps us.
Well, not just prediction, just the logic of science, period. And he thinks it's been so successful that whenever you get apparent counter examples, you should tell some story about it. Now, there are many disagreements between us about this. One is that classical logic is not the logic of science. And I've given you an example of why that's not the case with the Bohr theory of the atom. We haven't talked about the original infinitesimal calculus. So we disagree on that point. Second point is Tim has to make excuses for a lot of apparent counterexamples to the principles of classical logic. And I think he just goes over the top with ad hoc face-saving maneuvers. Now, of course, he doesn't think they're ad hoc, and he explains why they're ad hoc. I don't agree with his arguments, but that's part of where our debate has gone. So that's a sort of rough indication of why we disagree on the results of applying the abductive method.
Right. That's helpful. The second question I had was in context of the debate about revision of logic started by Quine. I kind of think that Kripke has the last word on it. I've been reading the paper, The Question of Logic, that was published in Mind a few years back. And in that, Professor Kripke, in the last section, produces a proof for the inconsistency of classical logic itself. So, and which is I completely do not get the way that he goes through that proof, but he thinks that it is a shame that people who have given so much time into classical logic were not able to see that there is this little inconsistency in it also.
Who gives this argument?
Saul Kripke, in his paper, The Question of Logic, which is based on the Princeton lectures.
So I'm missing the name. Tell me slowly.
Saul Kripke.
Saul Kripke?
Yeah.
And what is the paper?
The Question of Logic. He produces
was this the paper that was in Mind a couple of years ago?
Yeah. That's the paper.
Okay.
So, well, I do not completely get it. I wanted to ask you, since you knew Kripke in personal capacity, what was his actual views on the nature of logic? Like, so because he makes the distinction of the, he introduces this formal system fallacy that is in the philosophical landscape right now because of the incoming of so many logics in the 20th century. People have started to think that, we can just adopt this system and then reason accordingly into that. And then he says, no, that we're wrong. We have to use this basic thing called reasoning. So first question is like, what exactly does he mean when he says that reasoning?
Okay, look, I think you've misunderstood Saul's paper slightly. He does not give an argument for the inconsistency of classical logic. He thinks classical logic is correct, okay? What he does give an argument for is the fact that Quine himself is inconsistent, because Quine appeals to certain principles in the critique of Carnap, which seem to apply just as much to his own view. That's the critique of Quine, okay?
Right.
That's the first thing. Second thing is that what Saul actually argues in that paper is that there are certain principles of inference which cannot be argued for without using them. Now, I think he's right in that, okay, but he doesn't argue that's true of all principles of inference. He doesn't argue that he argues there are certain principles of inference you can't adopt without using them. He doesn't talk about rejecting them. That's different. And he doesn't take into account the possibility there might be other rational ways of changing your views other than giving an explicit argument. Okay. So although some people, like Romina Bierman, have tried to generalize Kripke's view, that's not really Saul's view. Saul had a very limited view, okay? And if you read Saul's paper carefully, you'll see exactly what he's arguing for. And he's not arguing for the correctness of classical logic, although he did think classical logic was correct. That's true. But that paper is not itself a defense of classical logic. It has a much more limited goal. Okay.
Yeah.
So read the paper carefully.
It's my reading of it was it was a meta-philosophical question, or the principle of revision for him was a bit metalogical in the sense that there has to be something we find something that is intuitively wrong in our reasoning, and then that can be changed, like the existential import issue that happened. But
we often reason like that. That's true.
Right.
We find something that appears to have gone wrong, and we try and get around it.
Yeah.
And it doesn't need to be a contradiction. It might be something else that appears to have gone wrong. But look, it's clear that logic is a theory and it's changed over time. That's not contentious because, it used to be syllogistic, and now if it's anything, it's classical logic. But plenty of people have thought that's wrong, like Brouwer and the intuitionists, and they've given different theories. So there are different theories of logic and different theories have been accepted at different times. That's not contentious. What's contentious is whether the change has been rational, and it jolly well better have been rational. Otherwise, we've got no reason for preferring classical logic to syllogistic. And then the only interesting question is, what is the rational process that's been going on here? That's the interesting philosophical question.
Right. Maybe I've read the last section wrong, but he explicitly says that in this little babyish formal system, classical logic comes out to be inconsistent. I'll read it again. Maybe I'm wrong.
Okay. Look, well, maybe I've read the thing wrong, but I don't think that was Saul's view. I talked to Saul about this several times before he died, and I'm almost certainly did not think that classical logic was inconsistent.
Yeah. That is what made me put this question also, because it's so completely counterintuitive, since how can he think that classical logic is inconsistent?
We'd have to sit down and look at what he actually says, and I don't have the paper in front of me, but I think you've just misinterpreted what he's saying there.
I'll have a look at it.
I'll have to interject. Due to the paucity of time, we'll just now we'll be moving on to the final question for this break. Ashutosh, can you just unmute and ask a question?
I'm sorry to ask. Press the wrong button. I don't have any question. I press the wrong. I do have a request. Can we move on to the second part of the discussion of the lecture?
Yeah, okay, that's perfect. That's what I was going to say. Okay, perhaps then we can move on to the second part. We have about 1 hour more at our hands. So, I think we have had a really good break and some really good questions and answers. So I believe we can, Graham, move on to the second part.
Okay. So Arahant, we have about an hour left, do we?
Yeah, about an hour.
Okay, that's good. All right. That's fine. Let me take a 2-minute break. First of all, because I need to close the blinds because the sun is now shining on my screen, okay? And also, I want to get a throat sweep to stop my voice going. So let's have a break for 2 minutes, okay?
Yeah, sure.
Okay, I'm ready when you are, Arahant.
Yeah, sure. We can go on.
Okay, so the first part of the talk was about paraconsistency, and the second part of this talk is about dialetheism. And dialetheism is itself one application of paraconsistency. I didn't talk about it when I spoke about the applications of paraconsistency because this raises many new issues, so I've kept this separate. So, first of all, I'm going to explain what it is, and then give you a brief history of it, and then talk about some of its possible applications. And there is a last section where I talk briefly about a couple of possible objections, sorry. But I might skip that because I'm sure that you'll have your own objections. We can do that if you want to. But let's get through the other stuff at least. All right, so definition of dialetheism. First of all, a dialetheia, it's a made-up word. A dialetheia means something like two-way truth or two truths. And a dialetheia is a statement A, which is both true and false. Or sometimes you see it put another way. If you think that not A is true, if not if A is false, so the semantics of first-degree entanglement, a dialetheia is an A such that it's both A and not A are true. On certain assumptions, those don't mean the same thing, but on most assumptions, they do. Okay, so that's what a dialetheia is. And dialetheism is the view that some statements are dialetheas. In other words, that some statements are both true and false. If you're thinking in terms of first-degree entanglement, the semantics I gave you, it's telling you that there are some things in the bottom left-hand quadrant. Okay. And as I said, the term is a made-up term. This one was made up by myself and my one-time close colleague, Richard Routley, who's now been dead, for 30 years. So it's a long time ago. Anyway, in the 1980s, we coined that term. And we coined it because at that time, the word paraconsistent was being used for both what I've told you already and for what we now call dialetheism. And people were getting very confused. So we needed a specific term for dialetheism. So we coined this term. Okay, now, warning. There's a word that paraconsistent logicians use, which is trivial. I mean, no, it's not trivial. The word is, quote, trivial, right? Trivial means that a theory is trivial if it proves everything, or if everything follows. So, if you use classical logic and you've got an inconsistent theory, it's trivial. If you've got a paraconsistent logic, it doesn't have to be. But there's also a word trivialism, which means you've got everything. That every statement is true, which is more or less the same as every statement is a dialetheia. Okay. So trivialism says that every statement is true, or if you like, every contradiction is true. And trivialism is distinct from dialetheism. So dialetheism tells you that some contradictions are true. Trivialism tells you that every contradiction is true, and these are quite different. It's different to say some politicians are corrupt and every politician is corrupt. They just mean different things. But if you're a dialetheist who's not a trivialist, then you require a paraconsistent logic for reasons that I hope are now obvious. It should be noted that the fact that you're a paraconsistent logician does not mean you're a dialetheist. So if you're a dialetheist, you probably need to be a paraconsistent logician, but not vice versa. So in the last part of the talk, I gave you various applications of paraconsistent logic, and none of those presuppose dialetheism. So if you think those are plausible applications of paraconsistency, you don't have to be a dialethist. And as a matter of fact, most paraconsistent logicians in the last 50 years have not been dialethists. So that's important that you distinguish between paraconsistency and dialetheism. All right. Now, let me tell you a little bit about the history of dialetheism. So when we talked about paraconsistency, I was at pains to point out that explosion is not orthodox in the history of Western philosophy. The same is not true of the principle of non-contradiction. The principle of non-contradiction is highly orthodox in the history of Western philosophy. Okay. It was put into orthodoxy in the history of Western logic by Aristotle, who argues for it in chapter Gamma of the Metaphysics. So in that, he has a bunch of arguments for the principle of non-contradiction, and these arguments really set the principle of non-contradiction into orthodoxy in Western logic. Okay, so first of all, Aristotle starts off with the statement of the principle of non-contradiction, and this is it. For the same thing to hold good and not hold good simultaneously of the same thing and in the same respect is impossible, given any further specifications which might be added to rule out dialectical difficulties. Well, that's essentially ambiguities, but don't worry too much about that. The important thing is it's a statement that you can't, that no contradiction can be true, which is obviously a rejection of dialetheism. Okay. And Aristotle's arguments set the principle of non-contradiction into orthodoxy, so much so that there really aren't many other arguments in the history of Western philosophy for the principle of non-contradiction. Maybe things have changed a bit in the last 30 years, but certainly people in the history of Western logic, with a few exceptions, notably Hegel, have just echoed Aristotle's view. All right. So you might think that Aristotle's arguments had better be good. Were they? They were not. One of the problems is that the arguments themselves are very tangled, and commentators can't even agree on what they're supposed to be, let alone how they are supposed to work. Aristotle has one very long argument, which is an elenchus, a sort of ad hominem argument. And then he has a bunch of sort of throwaway arguments. So let's have a look at the elenchus. Again, how exactly this is supposed to work is highly contentious amongst Aristotle scholars. But I think the crunch of it goes something like this. What Aristotle does is give an argument which goes as follows. Necessarily, if something's a man, it's a two-footed animal. So it's impossible for something to be a man and not a man. Sorry, it's impossible for something to be a man and not a two-footed animal. So it's impossible for something to be a man and not a man. All right. Now, it's pretty clear that man is just an example. Aristotle thinks you can run the same argument or argument of this kind for any other predicate you choose. And this is taken to be his argument against the principle of non-contradiction. It's impossible for something to be a man and not a man, and so on for all other things. Now, this is actually a terrible argument, because what has Aristotle established? Well, to put it in terms of modern logic, it's not the case that something is a man and not a man, right? despite what you might think, even if that generalizes, that does not establish that you cannot accept a contradiction, because you can have that and you can have its negation as well. So, of course, if you have both, you have a contradiction. But Aristotle is supposed to be in the process of giving you an argument against contradictions. So if he rules out the principle of non-contradiction on that ground, he's begging the question. And in fact, the principle of non-contradiction in this form is actually a logical truth in a number of paraconsistent logics. All right. So that's Aristotle's main argument. Now, as I said, after that, he has a bunch of throwaway arguments. And the most notable thing about these is that he changes the subject. So most of the following arguments are ignoratios, because they argue for something which he's not supposed to be arguing for. What he's arguing for, in a lot of the cases, is that it can't be the case that all contradictions are true. In other words, he's arguing against trivialism. And this is quite explicit in the text. You've got just the argument, the conclusion of the argument he gives. So he slides from it's not the case that some contradictions are true to it's not the case that all contradictions are true. All contradictions are such that they're not true. In fact, the conclusion is some of the arguments is weaker than that. It's that it's impossible to believe that all contradictions are true, which is weaker again. So other than the initial long elenchic argument, the other arguments are not good because they just simply change the subject. So Aristotle's arguments are pretty terrible. And this is not just my view. If you read Aristotle commentators on the metaphysics in the 20th century, starting with Łukasiewicz, the Polish logician and Aristotle scholar, they've all come to much the same conclusion. The arguments don't seem to work. So what I'm telling you is pretty standard amongst Aristotle scholars now. Despite this, they did establish the principle of non-contradiction into the orthodoxy in the history of Western philosophy, as I said. Okay. As I've just said, despite the bad arguments, the principle has hardly been challenged in the history of Western philosophy, with some notable exceptions, such as Hegel. And things changed in the last 40 years because of the modern dialetheism movement. And that really goes back to a book that I published in the first edition was in 1987, and it was called In Contradiction. So that's really what launched the debate about dialetheism in the contemporary context. All right. So dialetheism is the view that some contradictions are true. That doesn't tell you which ones are. And the next obvious question is, hi, Graham. Well, you think that some contradictions are true. Which ones? Fair enough question. And so it's a fair question and deserves a fair answer. Dialetheism itself will not tell you which contradictions are true. It will just tell you that some are. And which ones depend on what you think the plausible applications of dialetheism are. That's going to be contentious. Let me just give you, I think, 3 possible applications that have been argued for in the literature. The first one concerns the paradoxes of self-reference. So a lot of people think that dialetheism is simply a view about paradox of self-reference. It's not. That's just one possible application. But it is true that the paradoxes have taken up most of the literature space concerning dialetheism in the last 50 years. All right. So the paradox of self-reference are a family of paradoxes. They use self-reference, whatever that is, and they're very old. The earliest paradox of self-reference is the liar paradox. That sentence is on the screen now. And this was apparently invented by the ancient Greek philosopher Eubulides, roughly about the 4th or 5th centuries BCE. Okay, and many of you will have met the liar paradox. It concerns a sentence which says this very sentence is false. Okay, is it true or is it false? Well, if it's true, hey, it says that it's false. So if it's true, it's false. But if it's false, well, that's what it says. So it's true. Okay, this is the liar paradox. And it sounds like a logician's party game, but serious logicians have never treated it as such. There are many important debates about what to say about this paradox in medieval logic, both Arabic and Latin. And it's really been a cornerstone of the development of logic in the 20th century. The reason is that paradoxes of this kind turned up in a somewhat unexpected place at the beginning of the 20th century in the foundations of mathematics. So many paradoxes of this kind, such as Russell's paradox and the paradox of Borelli-Forti and so on, hit the foundations of mathematics, and there have been many debates about how to handle them. So what to say is one thing, but that they're important is not contestable, because these paradoxes produced a crisis in the foundations of mathematics 100 years ago. All right, so these are important examples. Now, there's absolutely no consensus about how you solve the liar paradox. Nearly everyone has assumed that the argument that I just gave you, there's something wrong with it. And the name of the game has been explain what's wrong. And in 2,500 years, we still don't know the answer, at least to judge by consensus, because there's still no consensus on what the answer to what's wrong with the liar paradox is. Okay. Now, if you're a dialetheist, you say, well, there's nothing wrong with the argument. Okay. No one until, actually, that's not quite true. I was going to say that no one until the 20th century said this about the liar paradox, that it's both true and false. Actually, that's wrong, because Hegel himself says that it's both true and false. So in the lectures on his lectures on the history of philosophy, he's got a chunk on Eubulides, and he says that the liar sentence is both true and false. Another example of Hegel's dialetheism. But he's about the only character in the history of Western philosophy I know who said that the way to solve the liar paradox is to say that it's both true and false. To the extent that there's a sort of received solution now, and there's no uniform agreement on this, but the most common solution that you hear now is that not that the liar sentence is both true and false, but it's neither true nor false. Because what we saw was that if it's true, it's false. If it's false, it's true. Maybe it's neither. And if it's neither, then you haven't got a problem. Now, this solution was put forward, or at least outlined, by Saul Kripke in a paper of 1975 called Outline of a Theory of Truth. And that had an enormous impact on discussions afterwards. So a lot of people nowadays think that the solution to the liar paradox is that the sentence is neither true nor false. The trouble with solutions like that is that they're subject to something called revenge problems. So revenge problems beset virtually every consistent account of the liar paradox. You just have to tweak the example a bit and you get the problem back. Let me show you how this works in the case of people who say that the liar sentence is neither true nor false. So we're going to assume that sentences can be true, only, false, only, or neither true nor false. Okay. Now I want you to consider the sentence which says this sentence is false or neither true nor false. Let's think about it. If it's true, it's either false or neither true nor false. You got a contradiction in both cases. If it's false, well, if it's false, then it's either false or neither true nor false. If A, then A or B. So if it's false, it's either false or neither true nor false. And that's what it says. So it's true. We got a contradiction. Now, the other possibility was it's neither true nor false. Well, if it's neither true nor false, then it's either false or neither true nor false. Same reason. So it's true. Our contradiction is back. So this is called a revenge paradox or an extended paradox. And so you haven't got out of the problem. You've still got the problem in a different guise. All right. Now, as you can imagine, this situation has been discussed extensively in the literature on paradoxes in the 20th century. But saying that the liar sentence is neither true nor false is not a get out of jail free move, because you've still got to deal with that problem, which is arguably the same problem. Okay. Now, solutions to liar paradoxes are extensive, they're technical, and I'm not going to go into them anymore, but this is just an indication of one possible application of dialetheism. Let me give you a second one. This is Zeno's arrow paradox. This is actually what's driving Hegel's remarks about motion that I gave you before. So if you wonder why he has that account of motion, this is it. If you remember the quote, he refers to the dialecticians of ancient dialecticians. He's referring to Zeno. All right. So this is the arrow paradox. The other paradox of motion is different. This is just the arrow. So remember what the arrow paradox is. You've got an archer, they fire an arrow, the arrow moves from the bow to the target. Consider any instant of motion. How much progress does the arrow make on its journey in that instance? Well, 0. It's just an instance. It's exactly where it is and nowhere else. So progress it makes equals 0. All right. The motion is composed of such instants. Well, because the temporal stretch between the bow and the target is composed of instants. Now, if progress made at each instant is 0, the progress made at the sum of the instants is the sum of zeros. Now, you can add 0 to 0 as many times as you like, even transfinitely many, and you will still get 0. So, progress made on the whole journey is 0. In other words, it can't get to the target. That's Zeno's arrow paradox, right? And we could talk about sort of the Russellian type solution to the paradox if you like, but let me just give you Hegel's solution, which I actually think is right. So it's dialethic. And the dialethic solution is that the arrow does make progress at an instant. Because it's in motion, it's where it is now, but it's already gone a little bit further because it's in motion. So it's not where it is now. That's what that quote from Hegel I gave you says, right? Because to be in motion is not to be simply to be here at one point of time and here at some other point at another. That will be true of something in motion or something stationary at each of those points at each of those times. It's different if the thing is in motion. What makes the thing in motion is exactly that it realizes a contradictory state. It's both where it is and it's also not there because it's gone a little bit further. All right. So that's a dialectic solution to Zeno's arrow paradox. It happens to be Hegel's, and it's another possible application of dialetheism. Okay, let me give you just one more. Many philosophers have held that there is something that is ineffable. In other words, our language, our concepts, those might not be exactly the same thing, but they're close enough for present purposes. There are some things which transcend our ability to speak about them, think about them. Okay, that is, there are many philosophers who've argued that something is ineffable. There are some things that are ineffable. Actually, many great philosophers. Let me just give you one or two examples. In Orthodox Christianity, it's Orthodox Christianity that God is ineffable because God transcends any human categories, which are, of course, the only ones we have. In Mahayana Buddhism, ultimate reality is said to be ineffable. For various reasons we can go into if you want, but that's certainly true. Kant tells us that when you make an assertion, you apply the categories. And he also tells us that the categories do not apply to noumena, they apply to phenomena. So you can't talk about noumena, and that's explicit in the first critique in several places. Wittgenstein, the Tractatus. Wittgenstein tells us in the stunning end of the Tractatus that you can't talk about some things, well, all the things that make language possible, like the form of a proposition. So you can't talk about the form of a proposition. Okay, they're just things that the way that language works that you can't explain in language. That's explicit in the Tractatus. Heidegger. Okay. Heidegger tells us that there's a difference between being, what it is to be, and beings, the things that are. And he tells us explicitly that you can't say what being is, because to do so, you have to treat it like a being, which it is not. All right. So there's a whole bank of philosophers, and there are some pretty, high-powered philosophers in that bunch who tell us that there are some things which are ineffable. Now, the rub is that they don't just tell you that it's ineffable, they tell you why. I mean, this view is not pulled out of thin air. They give you reasons. Now, if you argue that something is ineffable, you must describe it in the process of arguing that it's ineffable. So in the very process of arguing that it's ineffable, you're effing it. So if their views are right, then there are certain things which are not only ineffable, they're both effable and ineffable. Now, I'm not telling you that these views are right. You might just say, well, that just shows these views are wrong. And that's a possible move. But obviously, the philosophers in question did not say that. And if you or someone subscribes to one of these positions or some similar position, which provides reasons for thinking that there is something that's ineffable, you're in dialetheism land. You're dealing with something which is both effable and ineffable. And in the discussion of the last part of the talk, someone mentioned nothingness. That seems to be in this category as well, but I didn't mention it here because it's not as standard as any of these things. All right. So you've now seen what some possible applications of dialetheism are. The last thing I got some overheads on are possible objections. I'm not going to go through those. I think I'm going to end in a minute. We'll see if you come up with the objections for yourselves. But let me just point out something important about objections to dialetheism, because one can distinguish between local objections and global objections. So local objections, okay, let's go the other way first. Global objections are objections that contradictions can't possibly be true. It's kind of an Aristotelian position. So you need to give some kind of argument where true contradictions are off the table, period, right? So that's one kind of objection to dialetheism. It's a global objection. But you might have local objections too. You might say, well, okay, maybe let's agree that true contradictions are possible, but we want to know whether they provide a solution to a particular problem of self-reference, of motion, of the ineffable, whatever. And you might want to say, well, okay, I concede that true contradictions are possible, but I don't think that's the best solution to the lie paradox. And you might give an argument that there's a better solution to the lie paradox than dialetheism. That would be a local objection, not a global objection, because it's an objection to this particular application, not to dialetheism in general. Okay, so it is important to distinguish between local objections and global objections because they are doing kind of different things. All right. Having said that, I was going to run through a couple of global objections, but I'm going to skip those for now and just finish this part of the talk. I might come back to these if someone raises them. So what I've been doing in this second part of the talk is to explain to you what dialetheism is, something about its history, and something about its possible applications. That's actually the end of my slides. So let me finish there for the time being. And we've still got about 20 minutes left. So let's go back to the discussion and see if you guys want to ask questions, which I suspect you will.
Yep. Thank you very much, Graham. And yeah, anyone you have questions, please just raise your hand and we can go in order. Okay, Eric has a question to ask. Yeah, let's go ahead.
Hi again. I don't want to take up too much time, so if anyone else wants to speak, or that's a question, I'm happy to do it. To concede, but I'd like to go back to the ineffability argument. I find that really fascinating. I'd like to ask sort of what the basic assumption is that leads us to derive what appears to be a contradiction. So is the inference as simple as, well, gosh, it looks like we can refer to, either in language or thought, something that is inexpressible in virtue of the fact that we can name it, and therefore there must be something that we're talking about or thinking about, in that's how we end up deriving the contradiction, right? So is that the basic principle underlying this? Anything that we can talk about, there must be a something
sort of, but not exactly.
Okay.
It's a bit more nuanced than that, because each of the philosophers I've talked about gives an argument that something is ineffable.
Yeah.
And there might be some textual argy-bargy about what exactly that means.
Yeah.
But it's pretty clear that, at least in many cases, that means that you can say nothing, literally say nothing, actually nothing true, but nothing true or false either. Each of the people I mentioned has different arguments for this. All right, so Wittgenstein's argument are not Heidegger's, and so we go back to their particular views. This is the ontological difference in Heidegger. It's the philosophy of the picture theory of meaning in the Tractatus and so on. They're quite different. There's not a general argument here. You've got to subscribe to the views of the particular philosopher, and you may not do. But if you do, then you've got an argument that something is ineffable. Okay, so that gives you one limb of the contradiction. What gives you the other limb of the contradiction? Well, that you've just said something about it, and moreover, something you take to be true. And so it's self-refuting, or at least it's self-referentially inconsistent. It's like someone who says, I can't speak English because I've never done it in my life, and means it, right? It's that kind of ad hominem self-reflexivity. So there's a kind of self-reflexivity here, but it's for one horn of the argument, you give an argument for the conclusion. So you give an argument for a certain sentence, and the other horn of the argument is rather something you establish not by arguing for it, but by showing it. So it's a bit more complex than you sketched.
Yeah, I mean, there's a general worry here that if the principle is as simple as, it sure seems like it can talk about, the ineffable just because I can name it, doesn't that trivialize ontology in a sense, right? I mean, it becomes very easy to populate our ontology by that kind of argument, right?
Look, I think I'm going to disagree with you here. I mean,
Okay.
Again, you have to accept certain contradictions, but dialetheism is not committed to the view that all contradictions are true, just some are true. So you don't want to argue, look, God is ineffable and ineffable, therefore Donald Trump is corrupt and not corrupt. That would just be a silly argument, right?
Sure.
So you've got to do some hard work if you want to get more contradictions out of it. Maybe you can. Whether you can will depend on the details of the view of the philosopher in question. No, there's going to be no blanket argument because the considerations are very, very different in each case. So what you've got to do, and it may be the case that the views are wrong, and I'm not endorsing them, but what you've got to do is you've got to take the considerations marshaled by the particular philosopher or philosophers to the effect that something is ineffable, and you've got to show that you can wring something else out of it, which you don't want, because obviously these guys are quite happy with the contract. Well, obviously, okay, let me not talk about it. Some of them were happy, some of them weren't. That's a different matter. But you've got a lot of hard work to do. It's not a get out of, dialetheism is not a get out of jail free card, because, okay, you've got an argument for contradiction, right? Now, the fact that the contradiction is quarantined by the logic doesn't mean that you can't deduce in unacceptable things. Maybe you can. So in studies of paraconsistent theories, there's a theory of proving non-triviality, which is a bit like proving consistency in classical theories. You need to show that the inconsistencies really are quarantined. And so it's not a get out of jail free card for a paraconsistent logician, but it's certainly not a get out of jail free card for a classical logician, because you've got to do the hard work and actually wring out the unacceptable conclusions using, a legitimate principles of inference from what you've actually been told about the position. And that's obviously a lot of hard work if you've ever tried Kant scholarship or Wittgenstein scholarship or whatever.
I'll give this up, but I mean, if I understand you correctly, what it sounds like we have to do in order to get into the position to find this application of dialetheism, we have to at least take seriously the views of the philosophers in question in order to get to the position where we can recognize dialetheism.
Absolutely.
Yeah.
And I haven't endorsed any of them. Right. So I haven't offered those to you, those examples to you as something that I would endorse. There is one thing in this ballpark that I would endorse, and that's, I think, that nothingness is in this category. Which I didn't give you that example, but that's the subject of my next book, which is coming out hopefully in a few months because it's in press now. So I do think there's something in this ballpark, but the actual examples I gave you are not ones that I would endorse.
You just very briefly, you gave a talk many years ago when I at Ohio State on nothingness, and I asked you a question about it, and you got angry at me. So
Oh, I'm sorry.
I won't ask it again. Anyway,
I'm sorry about that. I didn't mean to.
It's fine. I think it was something. It's something in the ballpark of does everything exist, right? If nothingness exists, right? Does everything exist? You know, that sort of thing.
Oh, I see. Well, let me not get angry. I think that look. I think it does. Let me just spell out what I mean. I think nothingness is a mereological sum. It's a sum of no things. And I think that everything exists because it's the mereological sum of all things. So the view about nothingness is not orthodox mereology. The view about everythingness is orthodox mereology. There it's taken that all things have a sum. So I hope I've sort of atoned for my misdemeanors.
No.
By answering your question in a civilized fashion now.
So there are reference to the expressions nothing and something. It's just that they have different kinds of mereologies. Is that a fair
statement? Not something, everything.
Sorry, everything is what I meant to say,
Yeah, look, something is a bit different. There are perfectly good grammatical uses of everything and nothing in English as a noun phrase.
Sure.
Right? I've yet to find an example in English of the word something as being used as a noun phrase. Now, maybe that's just my limited imagination, but they're not easy to find. So I think the word something is only a quantifier. I think everything and nothing can be quantifiers or they can be noun phrases.
Okay. Thanks.
Eric, where are you now?
Ashoka University.
Oh, okay. Well, how long have you been there?
Gosh, I think 2019.
Okay. Well, that's a big move from Ohio State.
I was a grad student at the time, but
okay.
Last time we spoke was at UConn. I believe you're giving a talk there, and I think I mentioned this, and we had a chuckle because I was Stuart Shapiro's student, and we had some fundamental disagreements, but we don't need to.
Okay. Well, delighted to meet you again, if only virtually.
Yes.
Thank you, Eric. And we have a question from Vitika. Before that, Graham, can you just say what's the title of the book that you've got coming out in a few months, just so I can be on the lookout for it?
It is called Nothing in Particular.
Oh, okay. Yeah. Okay, Vitika, please, you can ask a question.
Yeah, so it was not very clear to me about which contradictions, like when you say some contradictions are true, so which ones? Like if you are a dialethist, do you have some sort of criteria or parameter to determine? I mean, obviously you cannot enumerate those things, but you must work with certain kind of criteria in order to understand and say that, okay, well, which ones are true, or for that matter, even the others which are false.
Good. No, this is a very natural thought, and I'm glad you raised that. Of course, being a dialetheist doesn't tell you which contradictions are true. That will depend on any particular application you want to make. And dialetheists will disagree amongst themselves about this. So for a long time, I agreed with J.C. Bill about a dialethic solution to the paradox of self-reference, but not about a dialethic solution to motion. Okay. So there's a disagreement here. But it would be nice for me to say, here's an algorithm. Contradictions of this kind are totally unacceptable. Contradictions of that kind are not. Okay, that'd be nice, but I can't do that. But that would be utopian. Let me try to explain why. You asked me when should I suppose that a contradiction is true? Let me ask you a slightly different question. When should you suppose that anything is true? Now, that could sound like a smart-ass reply, and I don't mean that. What I'm asking is, what are your criteria for accepting anything, let alone a contradiction? Okay, obviously that's a hard question. We could argue a long time about that. But I think David Hume, the great Scottish philosopher, got it right when he said, the wise person is the person who apportions their belief according to the evidence. So of anything, you believe it's true if there's good evidence for it. And if you believe it and there's no good evidence for it, then you're just gullible. That's a question about when you apportion your belief about anything. And exactly the same answer applies to contradictions. So how do I know whether a contradiction is true? Well, I look at the evidence for it. Now, what kind of evidence? Well, in matters of any complexity, you're not dealing with an isolated contradiction. You're dealing with a contradictory theory. Maybe a theory of truth in the case of the liar, a theory of motion in the case of the Zeno's paradoxes, a theory of the nature of language in the case of ineffability. These are big endeavors. And so you're going to be dealing with a theory. And now we come back to a question which arose in the last discussion as how do you choose the best theory? The discussion there was about theories of logic, but I indicated that what I said was quite general. It was about a theory of anything. So suppose you want to have a theory, suppose you want to know about the liar paradox, for example. You're dealing with the theory of truth. Now, there's a whole bunch of theories of truth around, right? There's some dialectic ones, there's some non-dialectic ones. You got to choose. And you choose the one which is best on the criteria, the sort of standard criteria of theory choice, namely adequacy to the data, simplicity, power, failure to use ad hoc hypotheses, etc., etc. And if an inconsistent theory comes out best on those criteria, then that's the rational belief, at least for the time being, until a better theory comes up. So it's taken me a while to get around to answering your question, but that's essentially the answer. Do you want to come back on that?
No, I think I get it. Thank you.
Okay, thank you, Vitika. Do we have any more questions from the audience? If so, please raise your hand. And I guess till then, I'll ask not necessarily a question, just a query of sorts. So yeah, the dialetheism part of the talk, I really like that, especially the part on the ineffable. I'm going to read a lot more into this. And briefly to state, like, my question is going to be about the idea of like meta-linguistic or meta-positions in philosophy or any sort of inquiry. So I'll just state outright, just for context, that I come from, like, sort of Lacanian position. That is my area, Lacanian psychoanalysis. I'm not sure if you're very familiar with that, but there's one almost slogan, an aphorism that he develops towards the end of his career, that there's no such thing as a meta-language.
Okay, let me just get the name. I'm sure you're talking about the Parisian psychoanalyst Jacques Lacan, right?
The French psychoanalyst Jacques Lacan.
Yes.
Yeah. Talking about him, so he he develops a position on how there's no such thing as a meta language, and he develops it in the context of his ideas, where he comes to the position that is different, but that there's a structural impossibility of any system achieving full closure without having an aspect of it, like having some structural failure in terms of closure, and that there's a remainder left there. So in that context of like, a structure never achieving full closure, or like an impossibility of structural closure, I find what I've understood about dialetheism quite valuable to think that through. And the question I want to pose is that, so if dialetheism claims that some contradictions are generally true within the system, then how does it account for the structural impossibility of any system in achieving full closure without appealing to a meta level position or a meta linguistic position from which the said contradictions would be identified, or can it explain any sort of failure in totalization without introducing the very metalinguistic position. Russell's paradox, set theory paradox, is an example from which Lacan develops. So more or less my question is around that.
Okay. Look, I'm hesitant to discuss Lacan and his words metalanguage and closure, because almost certainly doesn't define them, and he may well not mean by those words what I mean. So just take that as a caveat, okay? But to the extent that I would use those words myself, I'm in agreement halfway. Now, let me explain. I don't think there's anything such as a metalanguage. I mean, often when philosophers meet a contradiction, they try to get out of it by parameterization, essentially sort of turning it into a bunch of layers, right? And if you're dealing with language, that's metalanguages. That was, or something like it, was the standard solution to the liar paradox between, say, 1930 and 1975. And a dialectic solution to the liar paradox and similar paradox has always been strongly against any such hierarchy. There's only one language, and you can use that language to discuss its own properties. End of story. So to that extent, I'm in agreement with Lacan. Now, he infers that there's always going to be some residue, something left over. I mean, it sounds as though we're in the ballpark of Gödel's theorems here. I don't know whether he referenced those or not, but a standard interpretation of Gödel's first unprovable theorem is that any consistent theory is going to be incomplete. So there's going to be something left over. Now, I have a very definite view on that, and I suspect that the same would apply to Lacan, because that conclusion is made on the assumption that you can't accept a contradiction. Because the sort of argument that's being given in all cases is if you've got closure, you've got inconsistency. And a dialethist is going to reject that assumption. What closure can actually give you is an inconsistency at the point of closure. Now, so I think an appropriate solution to Russell's paradox and the appropriate account of Gödel's incompleteness theorems sees inconsistency at the supposed point of closure. There's actually a long discussion going on in the contemporary literature between dialethists like me and neo-Wittgensteinians like Adrian Moore, who we both agree that there's a problem at the point of closure, but where he sees that after the point of closure you get nonsense, literally nonsense. It's a kind of Wittgensteinian position where I see at the point of closure you get a contradiction. Where he sees meaninglessness, I see contradiction, and vice versa. So again, we're almost on the same page, but not quite. And it does sound a bit as though Lacan and I are on the same page here, because he takes a point of closure, as you put it, to give you something that's left over. And I think there's an inconsistency. Yeah, there's something left over and nothing left over, because the boundary is itself a point of inconsistency.
All right, thank you very much. That's quite insightful. Do we have any more questions from the audience? Okay, There is one question from Manav in the chat, and I quote, he says, my question is, what could it mean for a liar sentence to be true or false? True/false.
What do you mean by that?
Manav, would you be able to unmute?
I don't think I have anything in particular in mind when I asked that question. I was just curious to know, like, what could it even mean for such a sentence to be true or false? Because for me, I think it is devoid of any content. So I'd like to know what your view on that is.
Well, okay, even in classical logic, it's not devoid of content. It's simply false. So you have a very unusual view, okay? Most logicians will think that the contradiction is simply plain false, not devoid of content. But I don't know how much logic you know, but I mean, if you've done Logic 100 and been told that's how logic works, you know, everything's true or false, not neither, not both, end of story, then you might well be puzzled. Now, let me give you an analogy. In 1905, Einstein produced the special theory of relativity. And according to his theory, time runs at different rates in different frames of reference. In fact, it can even run backwards in one frame with respect to another. And the immediate reaction to Einstein was, what the hell does that mean? Because it doesn't make any sense from a Newtonian perspective. It really doesn't. You know, it's just plain false. All right. Within a few years, Einstein's view was accepted. Why did people change their mind? Well, they couldn't understand how you operate in the Einsteinian context because they didn't know the theory, they didn't know the mathematics. So to get to grips with what it means, so to speak, they've got to learn this new theory and how it works. So you may be experienced, if you've learned classical logic, one might say the same about that. To understand what it means for a contradiction to be true, you've got to understand, for example, first-degree entanglement and how logic works in that context. And then you might want to understand some of the examples, like the Bly paradox. But the point is that you've got to get your head around a new theory. So what's meaningful or not, as you put it, is not an absolute question. It's theory relative. And if you don't understand something, it may just be because you haven't got your head around the appropriate theory. Now, I'm not suggesting you should do that. That's entirely up to you whether you want to do the hard work involved in getting into some of these new theories. But if you are worried about what it means, I'm afraid there's no way of coming to understand without doing some of the hard work of getting and working in these new theories and seeing how they work. Sorry, I've rambled on for a rather long time. I hope I said something of relevance.
Okay,
Yeah, thank you for your response.
Still time, can I ask just one question?
Okay, sure. Yeah, we can take that, and yeah.
Yeah. So I mean, I was just wondering. So in relation to Hegel, so in Hegel's case, we get the category of contradiction. I mean, of course, there are many interpretations of the logic itself. I mean, Hegel's book, The Science of Logic. Some people take it, for example, Stephen Willgate, Richard Winfield, that it is a presuppositionless logic. So all the categories that Hegel is developing in the science of logic are from this presuppositionless beginning, and he is imminently deriving them. And we get the category of contradiction only when we are like 400-500 pages into the book. Then in the doctrine of essence, we get the category of identity difference, and then from there contradiction. So if one were to ask Hegel what justifies your category, having this category of contradiction, he would say, yeah, I'm not merely asserting it, but I have imminently derived it from that presuppositionless beginning of pure being. So, and it would not be question begging, it would not be a dogma just presupposed. So similarly, in the case, if the same question would be posed to a to a dialectic person, what would his justification for having this dialectic view would be? Wouldn't it be merely an assertion against against classical logic? Classical logic has one dogmatic assertion that contradictions are not true. There is, in opposition to that, there is another dogmatic assertion that no, well, some contradictions are true. But what justifies that? I mean, Hegel has a particular answer. Not everyone would agree with that, but certainly he has an answer to that. He has. So, what would your response to that kind of questioning would be?
Okay. Comment on Hegel and a comment on me. You're right that he derives the notion of a contradiction later, but that's the explicit category. He's been operating with contradictions ever since the beginning, because being and nothingness, these are opposites. Yet they're the same, and he derives the category of becoming, which is the union of these contradictory categories. It both is and is not. So even if the category appears later, he's been operating with it from the very beginning. Now, once you've got the category, that doesn't tell you whether things in that category are true or false. That's going to be a separate question. Right? I can give you the category of a unicorn. That's going to tell you whether things are unicorns or not. That's always going to be a separate thing. And final comment on Hegel is this. He certainly claims that his system is presuppositionless. I think that's just wrong, personally. And I've had many very orthodox Hegel scholars say that Hegel got it wrong. Okay. So that's about him. Okay. Now about me. If I think that a contradiction is true, it's not a dogmatic assumption. I give you an argument. I give you a theory. Okay? So take the lie paradox. I didn't just say, well, let's suppose it's true. There's a very famous argument for it. Okay. Now, the argument is actually embedded in something much more important, namely a theory of truth. I didn't give you the theory of truth today, but it's easy. You've got the T-schema and you've got a few other things. It's a very simple theory of truth. And so now we're back with the question of theory choice. So 2 points. First of all, I'm not giving you a dogmatic assertion. I've given you an argument. And secondly, that argument is embedded in a theory, and I've told you how we end up thinking that theory is the best theory. So I might be wrong, but there's no dogmatism about it.
Thank you. That really helps. Yeah.
All right. With this, we'll be closing the session, I guess. So firstly, I would like to thank Graham for such an engaging and interesting presentation. I personally gained a lot from it. I'm very, very sure our audience did so as well. And I would like to thank the audience for all their questions, their participation, and for staying for so long. It's been more than 2.5 hours since we started. So thank you all for joining us today. And we look forward to welcoming you for our future events. And the recording of this event will, I think, soon, by tomorrow, certainly be available on our YouTube channel. That would be the Philosophical Society at St. Stephen's College. So you can revisit the talk there. I certainly will be doing so myself. And thank you. And thank you once again, Graham. Thank you for taking out time. Thank you for answering all the questions.
Thank you for having me with you. It's been a pleasure. And good luck in your studies and whatever else you do.
Yeah. Thank you very much.
Yeah. Thank you, Graham. Thank you. Hope to see you in July in Hong Kong, maybe.
I look forward to it.
Yeah.
Suresh, I just have one request from you, bro. Is it possible for you to take Professor Priest's email ID? There are some questions. There are 5 or 6 of them that I need to ask, which won't be possible on this.
I'll take that. It's organized by St. Stephen, so I want to take that.
Oh, all right.
I can share that with you.
Thanks so much. I'll be grateful. Thank you very much, Professor.
You're welcome.
Thank you. Good day to you, Graham, and good night to everyone else. Bye-bye.
Bye.